Welcome to the DIY Honda Garage channel. This presentation covers DTC P1157, which indicates a high voltage condition in the A-frame air-fuel sensor 1 AFS air-fuel sensor circuit for the Honda Fit models from 2015 to 2020. The DTC diagnostic trouble code signals a problem with the circuit itself, potentially affecting the performance of the vehicle's engine and emissions control systems. The A-frame sensor plays a critical role in measuring the air-fuel mixture, which is essential for optimal combustion. Given the modern architecture of the Fit, this sensor feeds data to the Powertrain Control Module, PCM, to adjust fuel delivery and maintain engine efficiency. Proper troubleshooting of DTC P1157 ensures that the vehicle operates within specified parameters and maintains environmental compliance. DTC P1157 is associated with the AF Sensor 1, which is located near the exhaust manifold of the Honda Fit. This sensor is paramount in measuring the air-fuel mixture in real time to ensure that the engine runs efficiently and cleanly. It sends this crucial data to the PCM, or Powertrain Control Module, which adjusts fuel injection based on the sensor's readings. Without accurate data from the AF sensor, the engine may experience poor performance, increased emissions, and even potential damage over time. The improper function of this component could lead to higher fuel consumption and possibly a failure in emission standards. By maintaining and checking the AF sensor regularly, vehicle owners can avoid costly repairs and ensure compliance with local regulations. Several possible causes may lead to DTC P1157 being triggered. The first potential cause is a short circuit in the wiring connected to the AF sensor. This can create false signals to the PCM, resulting in high voltage errors. Another cause could be a failure within the AF sensor itself, meaning it no longer correctly identifies the air-fuel mixture. Additionally, problems with the PCM might occur where it fails to interpret the signals accurately. Poor connections or loose terminals can contribute to intermittent signals that confuse the control systems. Lastly, an open circuit in the wiring can lead to a complete loss of signal from the sensor to the PCM, prompting high voltage errors. Understanding these causes helps mechanics pinpoint the source of the problem effectively. The symptoms associated with DTC P1157 can significantly affect the vehicle's operation. One of the most noticeable indicators is the check engine light illuminating on the dashboard, signaling a problem that needs addressing. Drivers may also experience poor engine performance, such as a lack of power during acceleration or erratic engine behavior. An increase in fuel consumption can occur when the engine improperly adjusts fuel delivery due to faulty sensor data. Furthermore, the vehicle may fail in emissions test, as the AF sensor plays a pivotal role in maintaining compliance with environmental standards. Owners might also notice rough idling, where the engine struggles to maintain a steady RPM while stationary. Recognizing these symptoms early can save time and resources in diagnosing the primary cause. For the first troubleshooting step concerning DTC P1157, begin by turning the vehicle to the on mode without starting the engine. This allows the diagnostic tools, such as the HDS, Honda Diagnostics System, to fully boot and communicate with the vehicle's systems. Next, clear the existing DTCs recorded in the system using the HDS. After clearing the codes, it's essential to start the engine and let it idle for 1 minute to allow all sensors to initialize and stabilize. Subsequently, check for any pending or confirmed DTCs again with the HDS If DTC P1157 reappears, the issue has been duplicated, and you'll need to proceed with further troubleshooting. However, if no DTCs are indicated, then you may be dealing with an intermittent issue that will require inspecting the connections and terminals linked to the AF sensor and PCM. In the second step of troubleshooting for DTC P1157, you start by turning the vehicle to the off or lock mode, creating a safe environment to work in. You'll need to use the HDS to jump the SCS short circuit line, which is essential for isolating specific circuits for testing. The next step involves disconnecting the AF sensor, sensor 1, 4P connector, and the PCM connector C, 51P. This will allow you to check the respective wires for any faults without interference from the PCM or any other connected components. After disconnecting, check for continuity between test points specified. The AF sensor connector number 2 and PCM connector C number 48 should have continuity in good conditions. If there is continuity, then the AFS plus wire is confirmed to be functioning correctly, allowing you to proceed to the next troubleshooting step. If no continuity is found, then there is likely an open circuit requiring immediate repair. Following the investigation of the AFS plus wire, the next step entails performing an open wire check on the AFS minus line for DTC P1157. Similar to the previous step, ensure the vehicle is in the off or lock mode. Again, the AF sensor, sensor 1, 4P connector, and the PCM connector C, 51P, should be disconnected to avoid interference during testing. Continuity must now be verified between specific test points. AFS sensor, sensor 1, connector number 1 and PCM connector C number 47. If continuity exists between these 2 points, the AFS wire is confirmed to be intact and reliable. However, if the continuity check fails, there is likely an open circuit present within this wire segment. Identifying and repairing this circuit is crucial to restoring proper functionality to the AFS sensor circuit and resolving the high voltage condition indicated by DTC P1157. In the fourth troubleshooting step for DTC P1157, the action plan focuses on testing the AF sensor itself. Begin by substituting a known good AF sensor, sensor 1, to eliminate the possibility of a sensor failure being responsible for the high voltage reading. Once the replacement sensor is in place, reconnect all the connectors that were previously disconnected. After reconnecting, turn the vehicle to on mode to allow the HDS to communicate with the newly installed sensor. It's crucial to reset the PCM using the HDS at this point to clear any stored fault codes and to refresh the system's memory. Following the reset, perform the PCM idle learn procedure. This step helps the PCM recalibrate and understand the new sensor's output properly. Finally, check the HDS for any pending or confirmed DTCs. If DTC P1157 persists, it indicates that further actions are required, such as updating the PCM software or substituting a known good PCM for further diagnostics. After completing all troubleshooting steps, it's vital to conduct a final verification to confirm the successful resolution of DTC P1157. Start by ensuring that the DTC is no longer present in the system. This involves running the vehicle and checking the HDS to validate that no new trouble codes have emerged. Observing that the engine is running smoothly with no unusual noises or performance issues is a positive sign. Beyond the code clearance, conducting a readiness check is essential to confirm that all systems are functioning correctly. Additionally, if applicable, ensure that the vehicle passes an emissions compliance test. A successful repair means the AF sensor circuit is now operating correctly, resulting in optimized engine performance and lower emissions. Preventive maintenance is crucial in avoiding issues like DTC P1157 in the future. Regular diagnostic checks of the vehicle can help catch any signs of trouble before they escalate into significant problems that require extensive repairs. Routinely inspecting the wiring and connections associated with the AF sensor will ensure that you identify any wear or damage that might lead to intermittent circuit faults. Keeping the PCM software updated is essential, as software updates can improve sensor accuracy and vehicle performance. If the AF sensor shows signs of failure or abnormal readings, replacing it promptly can save considerable time and costs associated with more extensive repairs. Engaging in these preventive measures will help keep the Honda Fit operating efficiently and within emission standards. In conclusion, DTC P1157 signals a high voltage condition in the AF sensor, Sensor 1, circuit of the Honda Fit. This diagnostic trouble code highlights the importance of the AF sensor in optimizing fuel-air mixtures for efficient engine operation and emissions control. A series of well-defined troubleshooting steps have been outlined, from initial diagnosis with the HDS to checks on wiring continuity and sensor substitution. Preventive measures have also been recommended to ensure ongoing reliability of the AF sensor and associated circuitry. By maintaining a proactive approach to diagnostics and repairs, vehicle owners can enhance not only their driving experience, but also environmental compliance and overall vehicle longevity. Please like and subscribe to the channel. See you next time.